we're going to look at systems. That's where you have two equations and two variables. And we're going to solve both of those kind of put together, and we're going to find both variables. We're going to write that solution as an ordered pair because when we find the solution to a system of equation, that means we're going to have we're going to have a point where they cross. That's our total solution. So all of this boils down to what point do they cross at? So there are lots of different methods that we are going to use to solve these. You can determine which method to use by looking at the equations. So our first method that we're going to look at is going to be graphing equations. So we're going to find out where these two cross just by graphing the equations. Now, to graph an equation, the best thing to do is to make sure that you have y equals mx plus b. So if both of your equations are in y equals mx plus b form, then you can graph them and find the solution. So that's what we're going to look at today. So take a look here. So there's a couple of different solutions that you can have. So if we just have that one solution, that means that you're going to have two lines that cross at one point. So you can see in this example here that your graph or your two lines are going to cross right here, and it looks like the solution would be 3, 3. So when x is 3, y is 3, that would make both of those equations true at that point. If you look at the second example there, we have two parallel lines. So those are going to have no solution. They're never going to cross. So you'll remember that parallel lines are going to have the same slope. So if you end up with two equations that have the same slope, you'll know that there will be no solution. There will be no way for those two lines to cross. So remember that has same slope. And then infinite solution. This seems kind of silly, but once you look at these two equations, if they're the exact same equation, which would mean that they would basically lay right on top of each other, then you would have infinite solutions. They would cross everywhere on that line. So, and remember those lines continue on and on. That's where we get that infinite solutions from. So let's try this out. So we have an equation that's going to be y equals 2x minus 1. We're going to graph that in red, and then we're going to graph 1/3 x plus 4. So we're going to have to kind of recall back on how to graph equations. So we're going to start off with our red line first. And so our red line is going to start at -1. And I'm going to go up to right 1 and carry that out there. And then I can also go down down to left 1 and carry that out. So you want to make sure you kind of carry all these points out so that you can definitely be able to find out where those two cross to find the solution. So we have 1/3 x plus 4, so I'm going to start at 4. And 1/3 says I'm going to go up 1, right 3. So up 1, right 3. Hopefully you can see that's where the point where they're going to cross over. So I'll go ahead and make another one, another couple of them. And so if I wanted to make my two lines here, here's my blue line. It'll look something like this. And then my red line is going to look something like this. So you can see those 2 points are going to cross right here at 3, 5. So that would be your solution there, 3, 5. You want to find out where those two lines cross. That's your solution. All right, we have another example. You'll notice that on both of these examples, you have y already by itself. That's when you want to use this graphing method. Other methods that we'll learn, you'll be able to pick those out and be able to determine that as well. So let's look here again. We're going to just kind of refresh our mind on how to graph these. So I'm going to start out at 5. Let's make this red, make the top red, and then make the bottom blue. So our top equation, I'm going to start out at 5. And I'm going to go down to right 1, and just continue that on. I'll probably go maybe 1 or 2 more, and then can go up to left 1. And so here's my line right here. I may have to extend out a couple more points. We'll just kind of sort of check and see. And then I'm going to make my blue line. So I'm going to start out at 10. way up here. Then I can't, if I am supposed to go up 3, right 1. However, can't do that because I'm out of space. Plus, it's not going to go towards my line. I want to go towards my line. So towards my line, I'm going to go down 3, left 1, down 3, left 1. You can see already that we have our equation there, but our solution, excuse me. And so now we'll graph those to that line as well. Ta-da. And then this is where they cross. That's going to be our solution, which is going to be -1, 7. So just a couple of things I kind of want you to be aware of. Remember that you want both equations to be in y equals. So that's when we can use our graphing method. Both equations are on y equals or in our slope-intercept form. If they're not, you would want to use another method. However, right now for 5-1, that's all you're going to practice now. So both equations need to be in y equals, and then remember that the solution is going to be where the two lines cross. So where those two lines cross, whatever that xy point is, that's the solution. That means that when that x is that specific number and the y is that specific number, you plug them into both equations, they would both give you an equals. That means that whenever you find that specific x and y value, when you plug them into both equations, they would all be equal. So that's another way to look at that. So this is just the beginning of solving systems of equations. This is just the beginning of solving systems of equations. Hope you're excited as I am because I love these.